I'm indecisive, and I don't know what I want to do when I'm older. But an option I'm thinking of considering is being a heavy mechanic. What is a heavy mechanic? It's just a mechanic that specializes in heavy machinery. This video, I will be relating chemistry to my possible future job, a heavy mechanic. Safety is the number one rule, so we must address that first. Being safe in a lab with chemicals, glassware, solutions, and compounds can be similar in being safe with cutting, welding objects, and wedging, with using personal protective equipment. Health hazards from cutting, welding, and brazing operations include exposures to metal fumes and ultraviolet radiation. These include burns, eye damage, electrical shock, cuts, and crushed toes and fingers. Safety is the number one priority, so there must be proper equipment used along with a thorough understanding of the procedure so I can carry out my task without fail. Moving on to the first investigation we did in class, combustion. There are two ways that this can be incorporated into being a heavy mechanical engineer. The first is the work is tiring. Proper amounts of food is essential for not only being accurate and efficient, but also staying conscious and not passing out due to heat exhaustion in hot climates. The work could be overwhelming, which is why having a sufficient amount of nutrients could be beneficial. The second is combustion engines are a basic chemical process of releasing energy from a fuel and air mixture. A gasoline car typically uses a spark-ignited internal combustion engine. The modern tank is a result of a century of development from the first primitive armored vehicles due to improvements in technology such as the internal combustion engine, which allowed the rapid movement of heavy armored vehicles. All power generators are equipped with internal combustion engine. Moving on to investigation 2, energy transfer and conservation. When welding materials, the heat capacity is important to understand because welding is very accuracy based. If something isn't hot enough, it isn't malleable enough, so it could break. However, on the other hand, if it's too hot and too malleable, then it could be too easily to move, or it could come apart and detach and end up breaking anyways too. The correct amount of heat is necessary for the material welded to be successful. In investigation 4, atomic structure, halogen and xenon bulbs are perfect examples on how the atomic structure can connect to this career. Halogen bulbs have tungsten filaments housed in a quartz capsule and filled with iodine and bromine gases. Halogens are a type of incandescent light bulb which uses halogen gas in order to produce light. Each consists of a fused quartz or other heat-resistant glass arc tube with a tungsten metal electrode on each end. In a xenon headlight, electric current passes through the xenon gas to create an arc between two electrodes and generate intense white or bluish light that is often brighter than LEDs. Also known as high-intensity discharge (HID) lamps, xenon headlights deliver a white-blue light approximately 2 to 3 times brighter than a halogen. Halogen lamps are used in automotive headlamps under cabinet lighting and work lights. A danger with halogen light bulbs is that you should not touch the bulb with your fingers because they're super hot. Xenon bulbs are commonly used in vehicle headlights, but because of their characteristics, they can be used as lighting in the home or in a workspace. They last approximately 2,500 hours and are energy efficient. Even though xenon light bulbs may be super useful, their expensive cost drives people away. In investigation 5, the periodic table, knowing what compounds are made up of and what reactions would make what are useful in heavy engineering. The chemical reactions that occur for planes and helicopters to take flight is necessary for repairing/making heavy aircrafts. Just in terms of takeoffs, the correct chemical reaction needs to happen, which is where most problems become visible. You wouldn't want an engine on a plane failing, right? Investigation 6, chemical bonding. Something important to this career is to know how fuels differ. There are many types of fuels to power things, and to use the wrong one could be devastating to the vehicle. Some examples of different fuels are kerosene, solar diesel oil, gasoline, and biodiesel. Using the correct fuel responds to the mechanism in question. For example, adding diesel fuel to a gasoline car will cause damage to the tank since diesel gas is thicker than gasoline. Of course, there are some different cars that can handle diesel oil. However, most cars today use gasoline. Thin oils have a lower viscosity and pour more easily at lower temperatures than thick oils that have a higher viscosity. Thin oils reduce friction in engines and help engines start quickly during cold weather. Thick oils are better at maintaining film strength and oil pressure at high temperatures and loads. Investigation 8, chemical quantities. Fuel and takeoff are very important. The amount of compounds of fuel necessary for takeoff is fundamental for aircrafts flying. The proper distance per tank, which goes under the category of storage of fuel, needs to be known for the proper preparation for people to operate the vehicles safely. Investigation 9, combustion engines. Spark plugs are the most important when it comes to combustion engines. Why do spark plugs have to be correctly aligned? Well, first, what is a spark plug? As their name suggests, spark plugs are the spark of electricity that ignites the combustion needed to start your vehicle. Spark plugs emit a bolt of electricity across a small gap, igniting the fuel and air mixture that puts the pistons in motion and gets your vehicle up and running. Clearly, spark plugs are crucial to the health of your vehicle's engine and car. Why do they have to be correctly aligned? A misalignment will cause one or both electrodes to be burnt away. Stoichiometry. The purpose of combustion is to consume fuel efficiently to produce heat. There are three components of combustion: fuel, oxygen, and heat. The most common fuel sources in combustion process are fossil fuels, natural gas, oil, and coal. Fossil fuels are hydrocarbons, or organic compounds containing carbon and hydrogen. To maximize combustion efficiency, it is vital to consume or burn all the fuel, which is known as complete combustion. Stoichiometry is used to do this.